Line, the IP address. I mean, it's the whole reason an email, a cat video, or this very explainer gets to your screen and not somebody else's. So let's break down how this whole thing works.
Okay, so let's just start with a really basic question. When you look something up online, how in the world does that information travel from a server, maybe halfway across the planet, navigate this insane maze of wires and signals, and land directly on your specific device? Not your neighbor's, not the person down the street, but yours. Well, the answer is actually something you already understand from the real world. It's basically the digital version of the postal service. For a package to get to your house, it needs a unique address, right? Same exact idea here. For data to get to your device, it needs a unique digital address.
And that digital address has a name. It's called an IP, or Internet Protocol Address. Now, don't let the word protocol trip you up. All that means is it's a shared set of rules, a common language, that all the devices on the internet agree to use so they can talk to each other. It's literally the key that unlocks all online communication.
Okay, so this is where it gets really interesting, because it turns out not all IP addresses are created equal. The best way to think about this is to imagine your home Wi-Fi network is like a big apartment building. It has one main street address, but inside, there are tons of different apartment numbers. So your public IP, that's like the main street address of the whole building. It's the one and only address that the entire outside world, the rest of the internet, can see. Your internet service provider, your ISP, is the one who gives this address to your router, and it represents your entire household online.
Then you've got your private IPs. These are the individual apartment numbers. Your router acts like a building manager, handing out a unique private address to your laptop, your phone, your smart fridge, literally every single device connected to your Wi-Fi. And the key thing here is, these are for internal use only. The wider internet has no idea they even exist.
So let's just put it all together, right? You've got one public IP that your ISP assigns you. That's for talking to the whole world. And then inside your own little network, your router is in charge, handing out all these private IPs so your devices can talk to each other without getting lost. It's a pretty smart system.
I love this analogy. It makes it so clear. Imagine the public IP is a company's main phone number that everybody dials. But to actually talk to, say, Sarah in accounting, the receptionist has to connect you to her specific extension. That extension number, that's the private IP.
So, if we're using that analogy, who is playing the role of the receptionist? It's your router, of course. But how does it manage all that traffic? How does it know that this incoming data is for your game console and that data is for your laptop? Well, it uses a really clever process.
And that magic is handled by something called Network Address Translation, or NAT for short. Just think of your router as a super efficient mailroom clerk. When your phone wants to visit a website, it sends the request to the router. The router slaps its own public address on the request as the return address and sends it out. When the website sends a response back, it comes to the router, which then checks its log and says, this one's for the phone, and delivers it to the right internal private address.
All right, so you've got this public address, but here's the next big question. Is that address permanently yours, carved in stone, or is it more like you're just renting it for a while? This brings us to another really key distinction.
And yeah, that question really gets to the heart of our next big concept, which is the difference between a static IP address, one that's fixed, and a dynamic one, which is just temporary.
A static IP, yeah, that's like owning the deed to a house. It's yours, it's fixed, it's not going anywhere, and you usually have to set it up manually. A dynamic IP, totally different story. That's much more like a hotel room key. You're assigned one from a big pool of available addresses, you use it for a while, and the next time you connect, you might get a completely different one.
So how does this automatic assignment happen? Well, it's all thanks to a system called DHCP. That stands for Dynamic Host Configuration Protocol. And honestly, the best way to think of it is as the network's hotel front desk. It has a whole bunch of available IP addresses, kind of like room keys, and it just hands them out to devices as they show up and connect to the network.
So when would you use one over the other? Well, it makes perfect sense when you think about it. If you're a business and you're hosting a website, you need an address that people can find reliably, day after day, so you use a static IP. But for most of us at home, just browsing the web, a temporary, dynamic IP is perfectly fine. Plus, it's way more efficient and cheaper for ISPs to manage a pool of addresses they can share.
And you know what? That whole system of temporary, dynamic IPs, it turned out to be absolutely crucial. Why? Because the internet had a serious growing pains problem. A big one. It was designed like a small town, but it exploded into a global megacity, and it started running out of addresses. You see, the original system, the one we call IPv4, could only support about 4.3 billion addresses.
Now, back in the 80s, that probably sounded like an infinite number. But today, with billions of people online, each with multiple devices, yeah, we blew past that limit a long time ago. They've all been given out.
So to solve this, the Internet's architects created a new system, IPv6. And the number of addresses it provides, I mean, just look at that number. It's so ridiculously huge, it's hard to even wrap your head around. It's 340 undecillion. Basically, we now have a virtually limitless supply. We're not running out of digital real estate ever again.
And you can see the difference right away, can't you? On one side, you have the classic IPv4 address, those 4 blocks of numbers we're kind of used to seeing. And on the other, you have the new IPv6. It's much longer, way more complex, and it uses both letters and numbers. That complexity is what gives it that almost infinite capacity. All right, so we've gone through all the technical stuff, what an IP is, how it works, why there are different kinds. But let's bring it back home. What does all of this actually mean for you and your privacy online? What does your public address reveal to the world? Yeah, this is something a lot of people worry about, and there's a ton of misinformation out there. So let's just cut through the noise for a second and separate what's fact from what's fiction.
So here's what's true. Your IP address can give away some general information. Using a process called geolocation, someone can figure out what country you're in, probably what city or general region you're in, and which company is your internet provider. So a general ballpark location.
But, and this is the really important part, here's what it can't do. Your IP address by itself is not going to reveal your name, your exact street address, your phone number, or your email. It's much more like a zip code than it is your specific house number.
And that really leaves us with one final thing to think about. We know our digital address is public. Now, in the real world, if you wanted privacy, you might get a P.O. box, right? Well, there are digital equivalents, things like VPNs that can mask your IP address. And while that's a whole topic for another day, it really shows that understanding your digital address is the very first step to taking control of your digital life.